In question 1, it says the function f is defined by f of x. Determine whether f is an increasing function, a decreasing, or neither. Now, to determine whether any function is increasing, decreasing, or neither, uh, when can it be increasing? Let me just explain it to you very quickly. Look, let's say if the curve is only going upwards, it's an increasing function, but it is saying x is less than -1. Okay. So if x is less than -1, let's say this will represent increasing or decreasing? Decreasing function hoga, right? So let's say this is x equals to -1. If the graph was coming upwards like this, it would have been increasing function. However, it is also highly possible the graph could be like this, so it will be neither. Okay. So how do we basically represent increasing, decreasing functions? By finding the gradient dy dx. Okay. So you will write f of x is equals to 3x plus 2 to the power of -1 plus x squared. Now you will differentiate. When I differentiate this function, I will get -1 will multiply 3x plus 2. This will become -2 plus 2x. So this will become -1 upon 3x plus 2 whole squared plus 2x. Okay. Now this is the expression for the gradient. Now the value of x is always less than -1. If it is always less than -1, it means that the denominator will always be positive, because when you whole square any number, it becomes positive. Right? So the denominator is always positive. So this will basically be -1 upon a positive number. Let's say x is -1 for our case. Okay. Okay, I did not do one thing, and that is multiply this by 3. The derivative of 3x plus 2, a very common mistake which everyone should be very mindful about. So this should have been -3 up here, right? Okay, so this expression will become -3, right? Upon this will be a positive value, right? Plus 2 times -1 or minus x, whatever value I take. So can I say, for because all the values of x are negative, this will be negative, this will be negative. So the answer will always come out as negative. It will never be positive, right? Whatever value of x you assume, the denominator will be positive. This whole term will always be negative. This will always be negative. Negative and negative will always make a negative answer, which means that this will be a decreasing function, because the gradient is always decreasing or negative, right? So this is how you prove a function, whether it's increasing, decreasing. It is saying the graph of y is equals to f of x is transformed to the graph of y is equals to 1 plus half of x. Now f of x has been transformed to f y is equals to 1 plus f of half x. Now remember, this plus 1 represents a translation in the y direction, and this multiplication, this half x represents a stretch of scale factor 2 in x direction. If I multiply the whole function by a number, that is a stretch in the y direction. If only the x term is multiplying, that is a stretch in the x direction. So it is saying describe the two single transformations. I will say one of them is a translation of 0 and 1, and then you will write stretch scale factor 2 in x direction. Yeah. So the order will matter if the transformations are in the same direction, like in the y direction, the x. If one of them is in the x and one of them is in the y direction, like in this case, the order doesn't matter. Okay. All right. Moving forward. In question number 3, it says the diagram shows part of the curve with equation as given. The shaded region enclosed by the curve and the line y equals to 5 is rotated to 360 degrees about the y-axis. Now they have made this bold. Whenever it is rotated about the y-axis, you will make x your subject. So the first step in this equation will be making x your subject. So x square root of y minus 1. The formula to find the volume in this case will be the limits will be 5 and 1. And you will use this equation will we write x, no wait, x whole squared dx. Now listen, we'll whenever we find the volume, we'll whole square the equation first. Okay, so we will write in place of x, we'll have square root of y minus 1. We'll whole square this, and in the end add pi to the final answer, and this will be dy because we are doing it in terms of this is dy. Okay. No, whenever you have limits, you do never add plus c. Okay. Now, when I whole square this, I will get y minus 1. And now I integrate y, that will become y square upon 2. Integrate 1, that becomes y. Now I will put in the limits. The upper limit is 5. So that will become 25 upon 2 minus 5. And then subtract it from the lower limit, which is 1 upon 2 minus 1. 12.5 minus 5 is 7.5 minus 0.5 plus 1. 7 plus 1 is equals to 8. And then you add pi to the final answer. And that is your volume for me. In question 4, it says the curve has equation y equals to x square minus 2x minus 3. A point is moving along the curve in a way that at P, the y coordinate is increasing. The y coordinate is increasing means dy by dt is equals to 4. And the x coordinate is increasing. Increasing means positive at 6. Now, what we know is that dy by dt is equals to dy by dx multiplied by dx by dt, right? So dy by dt is 4, dx by dt is 6, which means your dy by dx will be equals to 4 upon 6, that is equals to 2 upon 3. Now we have the value of dy by dx from the equation that we have over here, which is y is equals to x square minus 2x minus 3. Dy by dx will be equals to 2x minus 2. Now we have this dy dx. We also have the value of dy by dx over here. We will equate them and get the value of x. And that is it. 3 times 2 is 6x. 6x will be equals to 2 plus 6, 8. And then finally, x will be equals to 8 upon 6. That is equals to 4 upon 3. Beta, if you had listened earlier, this is the equation of the curve. And then we find the dy by dx. And that's how you will find the x coordinate. Okay, in question number 5, we have to solve the equation tan plus 3 sine plus 2 upon tan minus 3 sine plus 1 equals to 2. So the first step you can do is you can just simply cross multiply. Okay, so let's start cross multiplying over here. We'll get tan plus 3 sine plus 2 is equals to 2 times tan is 2 tan minus 6 sine plus 2. Now in place of tan, I can write sine upon cos plus 3 sine. And it is always better that we simplify first. So let's bring the sine over here. 3 sine plus 6 sine will become 9 sine. 2 and 2 will cancel out. Tan will go on that side. 2 tan minus tan will become tan. So now once you have simplified this, you will get this upon sine upon cos. Sine and now before you do anything else, if you cancel sine out over here, you might lose marks because first you will cross multiply. You will bring the sine on this side. Sine is, sorry, this is sine. And now you will take sine common over here. You will get 9 cos minus 1 equals to 0. So the important thing to remember now is that what you will get is sine theta is equals to 0 and 9 cos theta minus 1 is equals to 0, which means cos theta would be equals to 1 upon 9. A very common mistake that students make, and I would want everyone's attention, is that students cancel this out. When you cancel this sign out over here, you lose out on possible solutions. So when I do not cancel it out, I have sine theta is equals to 0 and cos theta is equals to 9. And we have to give our answer between 0 and 90. Okay, so if you do sine inverse of 0, that is equals to 0. So one of the values of theta will be 0. It can be greater than equals to 0. So yes, one of the values will be 0. And then what is the basic angle? 83.620. And when you make it in the quadrant, because we cannot go beyond 90, so we'll make it only in the first quadrant, which is the positive quadrant for all sine, cos, and tan. So your final answer will be 83.6 and 0. These two would be your final possible answers. The coefficient of 1 upon x in the expansion. Basically, 1 upon x means x to the power of minus 1, right? So this is 5. I will first of all find 5 CR. I need to find out at what term I will get 1 upon x. A is, I will just ignore 2 over here, x to the power 5 minus r, and x power minus 2 to the power of r, and that power should be equals to minus 1. So this is 5 minus r minus 2r equals to minus 1. So minus 3r is equals to minus 6. R will be equals to 2. It means I will have to use this term 5c2, a to the power 5 minus 2, and a upon x squared to the power 2. 5c2 is 10 into 8x cube into a squared upon x to the power of 4. So this will cancel out and I will get 1 upon x as my basically algebraic term. And then in the numerator, I will have 10 times 8 is 80, 80 a square. So the coefficient is 80 a square is equals to 720. And that is it. 80 a square is equals to 720. So if 80 is equal to 720, a square is 72 upon 8, which is 9. When it says possible values, you will give both plus minus 3, right? Square root of 9. Okay? You want to note it down? Understood. Lovely. The question. Okay. Hence, find the coefficient of 1 upon x power 7. We have the value of a as 3, right? So let's write this expression as 2x plus 3 upon x squared to the power of 5. Now we need the coefficient of x power 7. So like we did over here, now instead of minus 1, I will have minus 7 over here. Okay. So I will write x to the power of 5 minus r multiply by x power minus 2 into r is equals to x power minus 7. So what will I get? 5 minus r minus 2r is equals to minus 7. So minus 3r is equals to minus 12. R will be is equals to 4. So what we will use is 5c4 to get x7. Okay, 1 upon x7. Clear? Better, because when we are trying to find when do we have 1 upon x7, we only care about the variables, not the number. So using this, we figure out we'll have to do 5c4. So now you write 5c4, right? 2x to the power of 5 minus 4, which is 1. 3 upon x square to the power of 4. Now 5c4 is what? I don't know. Is it 5? I don't know. Okay. Quickly tell me the answer. 5. 5 into 2 x 3 power 4 is 81 है ना? Upon x power 8. Am I getting x power 7? Yes, I am. So 1 upon x7 is over here. 5 times 2 is 10. 10 times 81 is 810. And this is the coefficient of 1 upon x7. This will be your answer. Make sure you exactly make a box like this in your exam as well. The diagram shows a sector AOB, which is part of the circle with center O and radius 6. And everyone should be attempting this question on their own as well. And I will also be doing it for you. But rather than just copying my work, it is better that you also do it on your own. With angle AOB is equals to 0.8, the point C is such that AC is perpendicular. The arc CD is part of a circle with center O. Okay. Find the area of the shaded region. Now, if this total length is 6 OB, that means OA is also equals to 6. That is the first information I have. Now, because this is a right angle triangle, this will also be a right angle. Now, using this, I can also find this length over here, because if I want to find the area of this total triangle, if I want to find the length of AC, let's say if I want to find the length of AC, I will write opposite over hypotenuse. So sine of 0.8 is equals to opposite, which is AC upon 6. What is the value of AC? Make sure your calculators are in radian mode. 4.8 and आगे 438 304. Okay. And now we'll find the length of OC. So OC will be adjacent over hypotenuse. So cos of 0.8 is equals to OC upon 6. So OC will be what? Quickly. 4.180 centimeters. Now, why was it important in this case to find these lengths 4.16, 4.180? I will I will not worry about the accuracy at the moment. Listen, to find this area of the shaded region, I will want to find the area of this triangle OCA. I will want to find the area of this sector ODC. But to find the area of this sector ODC, I will need the length of OD, which is the same as the length of OC, right? So I already have OC now. All right. With what? Yeah. So if OC is 4.18 and AC is this, can I say the area of triangle OAC? And again, I will repeat myself. When you are giving your mock in your exam, in your school or over here as well, you will have to make sure you're working as clear as this. What area am I finding? Area of OAC. Half into 4.304 into 4.180. Can I know the exact answer for the total area of this triangle? Everyone, please do it. So in case someone makes a mistake, you have the correct answer. 8.995. We will only round off our final answer to three significant figures. 8.995. Lovely. Thank you, Ajay. Now, finding the area of sector. What is the name of the sector? ODC. Yeah. In this case, the radius will be 4.180. And we know half r square theta. Na? So 1 upon 2 r square theta is the formula. So 1 upon 2 into 4.18 whole squared into theta is 0.8. What is the area of the shaded region? Oh, of sector? 6.989 cm square. Finally, you will write area of shaded region is equals to 8.995. This is what you will substitute in the calculator as well. Answer. Give answer to 3 decimal place, please. 2.006, right? So 2.01 cm square would be the correct area of the shaded region. To connect to three significant figures. Sorry. FIFA. Okay, a woman's basic salary for her first year. At the end of the year, she also gets a bonus. For her, so we are back in O levels with this question. Express her bonus as a percentage of the basic salary. 600 upon 30,000. I have no idea why I will ask this question, but they have. So, so 1 upon 50 into 100. This doesn't even need a calculator, mashallah. At the end of each year, the woman's basic salary will increase by 3%. And her, okay, now this is very important. Her salary will increase in geometric term. Her bonus will increase in arithmetic term. Okay. Express the bonus she will be paid at the end of her 24th year as a percentage of the basic salary. So first of all, at the after 24 years, what will be her basic salary? Let's figure that out. We know the nth term of a GP because it will be GP is given by this, and the common ratio will be what 1.03. Yes, excellent. 103 upon 100. So the first term was 30,000 into R, which is 1.03, into 24 minus 1, which is 23. So what is her uh, salary? And simultaneously, on the other end, I will also find her bonus while you people calculate it on the calculator. So her first bonus was 600 plus n minus 1, which is 24 minus 1, into difference is 100 every year. So 600 plus 2300, that is 2900. So what was this answer? What he's saying 5920? Acha, 5. Okay, now you have these both of these values. So the percentage will be again 2900 divided by 59207.6 times by 100, whatever the answer is. Whatever the answer is, I would want to know, obviously. Hmm? Says 4.89 or 4.9. 4.90% to 3SF beta. You got 4.898 now? I mean, yeah, 4.90 will be the correct answer for 3SF. Okay. In question number 9, it says express this in the form. Now, there are two ways you can do it. You can complete the square or you can do comparison method. Whatever method you like, I mean, you can do it. I prefer, I don't have a preference, honestly, but let's use the comparison method. We will expand. If it says by completing the square, in that case, you will definitely have to complete the square. If it doesn't say so, then you can use any method. So I'm using the comparison method. You will expand this side. This will become 2x square plus 4ax plus 2a square plus b is equals to. Now you compare. With x, I have 12. With x, I have 4a. So a will be 12 upon 4, that is equals to 3. And the constant term is 2a square plus b, and over here that's 11. So I will say 2a square plus b equals to 11. A is 3 square 9. So b will be 11 minus 18, which is minus 7. So the final answer will be 2 into x plus 3 whole squared minus 7. So that's the first bit. Okay. Find an expression for f inverse of x. Now, finding the inverse function is exactly the same as what you did in O levels. But for A levels, the only difference is that if you have quadratic term, the method will be the same. When we have to find the inverse of a quadratic function, we always bring it in complete square. In part A, we already did that over here. So let's write f of x as 2 into x plus 3 whole squared minus 7. Now again the same steps that you learned in O levels. You write y over here, then you exchange the values of x and y, or whatever you make y the subject, whatever you prefer. And finally, so this will become x plus 7 divided by 2 is equals to y plus 3 whole squared. Then you square root both the sides. And then finally, y is equals to square root of x plus 7 upon 2 minus 3. I will always prefer that once you do this, you also write your answer like this in the end. Now the important bit comes in. The important bit comes in, state the domain. When we talk about the domain of f inverse, it basically means what are the possible values of x we can take over here, right? Domain means the values of x. So x has to be less than equals to minus 4 for this function over here. Okay. What we also know is that domain of f of x is the range of f inverse of x, and simultaneously I can do it the other way around as well. Range of f of x is the same as domain of f inverse of x. Okay. Now look at this question, beta. And I would want you to understand a couple of things because with function that is important. I hope you people know that these points give me the turning points, right? Okay. And this will be a minimum point. So can I say the turning point is minus 3 and minus 7? Okay. So the minus 3 and minus 7, this is the turning point. If they ask me to sketch a graph, it would be somewhat like this. Okay. And this point would be minus 3 and minus 7. So that's the first thing. Now, when it says x is less than minus 4, so let's say minus 4 is over here. At minus 4, what will be my y value? Can you quickly tell me? When x is minus 4, what is my y value? 2 into minus, mentally कर लो जल्दी से, 16, 32, minus 48, minus 16, 11, minus 5 है ना? Mentally मुझसे fast. Anyway, so देखो, what I know is that the curve is now going up. It is going up. Yes. Can I say that this function f of x for this value of x, f of x will be greater than equals to minus 5? Do you all agree with this? Because देखो, I'll tell you what, x is minus 4 and x is always less than minus 4. As I go lesser than minus 4, the value of the function will keep on increasing, right? Yes, it will always keep on increasing, huh? No, but I want you to learn something through the graph so that you can at least apply this in your exam. Okay? You can do it directly as well, but this helps you to understand better. So just by looking at the graph, you know my graph is always going up from minus 5. So this f of x will always be greater than minus 5. So can I say if the range of f of x is greater than equals to minus 5, then the domain of f inverse will also be x is greater than equals to minus 5. So when they ask me for the domain, x will always be greater than equals to minus 5. And that's it. Now, what you can also understand from this function is, Azan, in part C, it says that the function g is defined by g of x is equals to 2x minus 3 for x is less than k. Now, in part C, we have to we have to solve the equation f g of x is equals to 193. Now we know that f of x is equals to, so from the previous part that was equals to 2 into x plus 3 whole squared minus 7. Now when we are finding fg of x, so it means in place of x, we'll substitute the function g. So that is 2x minus 3. And then we'll equate it to 193. So this will become 2 into 2x whole squared minus 3 plus 3 will cancel minus 7. And that is equals to 193. So this becomes 8x squared minus, so 2x squared is 8x squared is equals to 193. 8x squared will be is equals to 200. So we'll get the value of x squared is equals to 200 upon 8, that is 25. So x will be is equals to square root of 25, that is equals to plus minus 5. Now in part D, it says state the largest value of k possible for the composition fg to be defined. Now, if the question says state, that means there is no working that we have to do. But to figure this out, what we know is that this function f of x is defined for values of x is less than -4. When we talk about f g of x, that basically means in this function f of x, this x is being replaced by this function g. Now we know that this function g is 2x minus 3, which means that this value of this function 2x minus 3 that we have, and as it is representing the x value, and this x value cannot be less than or equal, it has to be less than equals to -4, which means that we'll have to equate g of x as equals to less than equals to -4. Solving this equation, we'll get 2x is less than equals to -4 plus 3, that's -1. So x will be less than equals to -1. So the largest value of k will be k is equals to -1. K was basically the x value of g over here. And we know that this whole function in fg represents the x value in f of x. So this value has to be less than equals to -4. So for this value, the value of x will be equals to -1. So the value of k will be equals to -1. In question number 10, the gradient of the curve at the point is given by dy dx equals to 2x plus 3 power half minus x. The curve has a stationary point at a comma 14. Now, stationary point means dy dx is equals to 0 and a is the x value. So we'll write 2 into x plus 3 power half minus x, and that is dy dx equals to 0. Taking x on the left hand side, we get 2 into x plus 3 power half is equals to x. We'll whole square both the sides to cancel the power half. So we'll get 4 into x plus 3 is equals to x square. So bringing 4x, so this will become 4x plus 12 is equals to x square. We'll get x square minus 4x minus 12 equals to 0. We can solve this by factorization. So we'll get x minus 6 and x plus 2 as a value. So when it says the value is a positive constant, so the only value of x will be x equals to positive 6. In part B, it says determine the nature of the stationary point. Now, to determine the nature of the stationary point, we'll have to differentiate the expression for dy dx. So we know that dy by dx is equals to 2 into x plus 3 to the power of half minus x. Differentiating this again to get the double derivative, we will get, so this will be half into 2, that's 1, into x plus 3 to the power of, this will become minus half, and the derivative of x plus 3 is 1, so we leave it as it is, and then this will become -1. Now over here, we'll substitute the x value, so we'll get the x value, which is 6, and this will become, we can write it as 1 upon 6 plus 3 to the power of positive half minus 9, minus 1. So this will become 1 upon 9 power half, which is 1 upon 3 minus 1, that is equals to -2 by 3. As it is negative, which it means that the nature will be a maximum point. If it is negative, it's maximum, and if it was positive, it would be a minimum point. In part C, we have to find the equation of the curve. So to find the equation of the curve, we'll integrate the expression for dy by dx. The dy by dx expression is given as 2 into x plus 3 to the power of half minus x. Integrating both the sides, we'll get y is equals to, so increasing the power by 1, we'll get half plus 1, that's 3 upon 2. We'll divide by 3 upon 2 and also divide by the derivative of x plus 3, but that is 1. And then write integrate x, which will become x square upon 2, and we'll add a constant. So y will be is equals to, this 2 will come up in the numerator, so that will become 4 upon 3 into x plus 3 to the power of 3 upon 2 minus x square upon 2 plus c. And now we already have a point on the curve that was a and 14, and the value of a was 6. So we'll substitute 6 and 14 into the equation to get the value of c. So we'll get 14 is equals to 4 upon 3 into 6 plus 3, that's 9, minus 6 square, 36 upon 2, that's 18, plus c. So square root of 9 is 3, 3 cube is 27. So you'll get 14 is equals to 4 times 27 upon 3 minus 18 plus c. So this will become 4 times 9, 36, minus 18. 36 minus 18 is 18 plus c. So the value of c is equals to minus 4. Finally, now we can write our equation as y equals to 4 upon 3 into x plus 3 to the power of 3 upon 2 minus x square upon 2 minus 4. In question number 11, we have to solve the equation 3 tan square minus 5 tan minus 2 equals to 0 for 0 to 180. So in the first step, we can solve this quadratically. We can apply middle term breaking as well. We'll get 3 tan square minus 6 tan plus tan minus 2 equals to 0. Taking 3 tan common, we'll get tan minus 2. Taking 1 common, we'll get tan minus 2 equals to 0. So we'll get tan theta is equals to minus 2 and tan theta plus 2. So this will be a plus 2 and tan theta will be equals to negative 1 upon 3. Now once we have this, we have to find the values of x between 0 and 180. Now we will make the four quadrants and we know that tan is positive in the first quadrant and it's negative in the second quadrant. So first taking the positive value of tan, we'll find tan inverse of 2. So taking tan inverse of 2, in this case, theta will be, we are getting 63.4349. So this angle will be equals to 63.4 degrees. Now taking tan inverse of 1 upon 3, we'll first find the basic angle. So that will be equals to tan inverse of 1 divided by 3, that is 18.43. Now we'll make this basic angle in the negative quadrants of tan, which is the second and the third quadrant. However, as we already know that we cannot go beyond 180, so we'll just make it in the second quadrant. And to find the angle value of theta, we'll measure it from anticlockwise from the x-axis. So the value of theta will be 180 minus this answer. That will be equals to 161.56. So the final answer to one decimal place will be 161.6 degrees. In part B, it says find the set of values of k for which the equation has no solutions. Now, we know from quadratics, and this is a quadratic form, that a quadratic form will have no solution when b squared minus 4ac is less than 0. From our equation, we know that the value of a is 3, the value of b is minus 5, and the value of c is k. So we'll write minus 5 whole squared minus 4 times 3 times k as less than 0. We'll get 25 minus 12k as less than 0. And finally, taking 25 on the right hand side, we'll get 12k as less than minus 25. Switching the signs, so this will also, this sign will flip. We'll get k, 12k will be greater than 25, and finally k is greater than 25 upon 12. So these are the set of values of k for which the equation has no solutions. Now in part C, it says for the equation 3 tan square minus 5 tan plus k equals to 0, state the value of k for which there are 3 solutions in the interval and find the solutions. Now to understand that if there are 3 solutions, what that means is, and we have the interval between 0 to 180 again over here. So we can only find angles in the first or the second quadrant. Now we know that tan is positive in the first and it's negative in the second quadrant. Now, for us to have 3 solutions, it means that one of the solutions should be giving us, one of the values of tan should be giving us 2 solutions, and one of the values of tan should be giving us 1 solution. Now, if we just take a positive value of tan, let's say if we get tan theta is equals to 1.2, let's say we'll get 2 values, but one will be in the first and the third quadrant. And if we take a negative value, then we'll only have one value over here in the negative quadrants of tan. So if we, let's say we took tan theta equals to minus 1.2. Now, in this case, what we should know about the tan graph is that tan theta, when tan theta is equals to 0, the values of theta is 0 and 180. So if we substitute tan 180 in the calculator, we'll get a 0. And if we substitute tan 0, that will also give us a 0. So it means we need one of the values of tan to be equals to 0, and uh, from the other value, we'll get one more solution. So that will happen if this value, the C in this quadratic form, let's say if you have a quadratic form over here, if this thing is equals to 0, we'll get ax square minus bx is equals to 0. When we take x common, we get ax minus b, and this x becomes equals to 0. So in this case, the value of k that will give us three solutions will be the value of k will be 0. We will get 3 tan square minus 5 tan equals to 0, as now k is 0. Taking tan common, we get 3 tan minus 5 equals to 0. Now we can see that tan theta, one of the values of tan theta is equals to 0, and the other value of tan theta is equals to positive 5 upon 3. We already now know that tan theta is 0 when uh, theta is 0 and when theta is 180. And to find this value, we'll first find the basic angle, which is tan inverse of 5 upon 3. That is equals to 59.036. So we'll make this 59.036 in the positive quadrant over here. And the value of theta will be again measured anti-clockwise from the x-axis. So theta in this case will be 59.0. So the three values of theta will be 0, 59.0, and 180. In question number 12, a diameter of a circle C1 has endpoints -3, -5, and 7 and 3. We have to find the equation of the circle C1. Now we know that the equation of a circle is given by x minus a squared plus y minus b squared equals to r squared, where a and b are the coordinates of the center and r is the radius. Now we have the endpoints of the diameter, which means that the midpoint will be the center. So first finding the midpoint, we will get minus x1 plus x2. So minus 3 plus 7 upon 2, comma, minus 5 plus 3 upon 2. That will be equals to 4 upon 2, 2, and minus 2 upon 2, that's minus 1. And to find the radius, we'll first find the distance, which will give us the diameter. So the distance of these 2 points will be x2 minus x1, 7 minus minus 3, that is 10, plus 3 minus minus 5, that is 8. So the distance is square root of 164, which is basically the diameter, which means that the radius would be equals to square root of 164 upon 2. Finally, we can write the equation as x minus 2 squared plus y minus minus will make it a plus 1 is equals to 164 upon 2 whole squared. Simplifying this, the final answer will be 164 upon 2 square is 4, so that will be equals to 41. 164 upon 4 is 41. In part B, it says that the circle C1 is translated to give circle C2. We have to find the equation of the circle. Now we know that the coordinates of the center of C1 were 2 and -1. Now when we translate it by 8 units in the x-axis, so that will now be at positive 10, and then it will move 4 units upwards. So -1 plus 4, that will make it positive 3. So we can first write the coordinates of the center were 2 and 1, and we'll add 8 and 4 to it, which will make the center now 10 and positive 3. So the equation of circle C2 will be x minus 10 squared plus y minus 3 squared is equals to, the radius remains the same, and that we'll write it equals to 41. In part C, say that two circles intersect at point R and S. We have to show that the equation of the line RS is y equals to minus 2x plus 13. Now, we have the points over here R and S, and as the two circles are exactly identical and they're intersecting at 2 points, that means that the line joining the points R and S will exactly be perpendicular to the centers of these two circles, and it will be passing through the exact midpoint. Now, to show that the equation of the line RS is this, we'll first find the gradient of the centers. So the coordinates of the centers were 10, 3, and the other was 2 and -1. So finding the gradient, we'll get -1 -3, that will be equals to -4 divided by 2 minus 10, that is equals to -8. Now, the gradient of the line joining the center is 1 upon 2, which means that the gradient of the line joining RS will be -2. And as it is passing through the midpoint, we'll find the midpoint of the centers. That will be 10 plus 2 upon 2 and minus 3 plus minus 1 upon 2. So that will be equals to 6 and 1. Now, once we have the points and we have the gradient, we can find the equation y minus 1 is equals to minus 2 into x minus 6. Simplifying this, we'll get y is equals to minus 2x plus 12 plus 1. So we had to show that the line joining the equation of the line RS is y equals to minus 12 2x plus 13. So we have shown it over here. Now in part D, it says, hence show that the coordinates of R and S satisfy the equation 5x square minus 60x plus 159. Now we know that one of the equations is x minus 2 squared plus y plus 1 whole squared equals to 41. And as we know, this line is intersecting the basically this line R joining RS is at these intersecting points. And we have the equation of this line as well. We can substitute in place of y, we can write minus 2x plus 13 plus 1 whole square equals to 41. So this will become, when we simplify this will become minus 2x plus 14 whole squared equals to 41. Expanding the left hand side, we'll get x square minus 4x plus 4. Expanding this, we'll get positive 4x squared minus 2 times 2 is 4, 4 times 14 is 56. And then 14 square is 196 equals to 41. Simplifying, x squared plus 4x squared is 5x squared minus 4x minus 56 minus 60x. And then 4 plus 196 is 200 and 200 minus 41 is 151. So we had to show that the x coordinate satisfies the equation 5x squared minus 60x plus 159 as it's shown over here.